was talking about in the video. So for example, if I give you x equal to 3, it's just a line parallel to the y-axis, so through x equal to 3. And then if I extend it to 3D, it gives you a plane that it's like pulling this line. So I'll get that. And it's parallel to the x-axis, to the z-axis, so you can see that here. Okay, perfect. So let me remove that. The second one we saw was y equals 3 minus x. So this, if I just do it in 2D, it'll be a line going through the points 0, 3, and 3, 0. Now if I extend it, imagine it's the same idea as x equal to 3, but it'll be slanted in the direction of x, y, okay? So it'll look something like that. Okay, let me see if I can show you this. All right, so there it is. A little bit, okay? Now again, this was very hard for me to draw. If I give you x in between -1 and 3, then it's all that strip, right? X goes from -1 to 3. Let me maybe make it closer. What is going on? Okay, there it is. It's like super sensitive in my laptop for some reason. Okay, but it goes from -1 to 3. If I extend it to 3D, notice that the only restriction is on x. So x goes from -1 to 3, so y is free. It takes every single value of y. But on top of that, I'm going to extend it to 3D, so everything will go up and down. It's like having infinitely many copies of this little sheet of paper. So it looks something like that. Look at that. That's what I try to draw. And finally, we have this x squared plus z squared equal to 64, which in this case, it means that 64. So let me make it there. Okay, there. Stop. It's usually not this bad. Okay, so it is a circle. Let me just show you the way I think about this is like, imagine I always think about it like I'm going to draw it on since there's no y, I'm going to draw the circle on the xz plane, right? This is the x-axis and the z-axis. So this will be the xz plane. Okay. So now if I remove that, then it'll be a three-dimensional cylinder, right? It'll be a three-dimensional figure, so it'll be a cylinder. So then it looks like this. Now, if I have exactly equal to 64, it'll be a cylinder, center at x equal to 0, z equals to 0, and then y is free. And if I replace equal sign with less than, it's the interior, okay? And if I do the interior and I do x squared plus z squared equal to 64, then that gives me the bound, okay? Which maybe if I make it like that, it's, I mean, of course, you know, this is not actually continuous. So it's like, imagine if you had infinitely many of this, it'll be solid. Okay, perfect. And since math never lies, let me show you what we just did, okay? So this is, as usual, let me make it so that it looks like what we're used to. And this is the equation of the sphere we just found, and this will be the intersection with the YZ plane. So if I don't put the x equal to 0, this is a cylinder, we discussed that, right? Well, it makes no sense. I'm looking for the intersection with the YZ plane. So I have to tell it, hey, x must be equal to 0. So x must be equal to 0. And then I don't see it because it should be somewhere here. Oh, where is it? Oh, it's right here. So so the intersection of the sphere with the YZ plane, it's when x is equal to 0, it's just a circle. Center at 6, 6, right? You see here, 6 and then 6, and radius √8. Okay, hope that makes sense.